Hi friends, welcome back in the another video of the computer vision. So today we will see a case study on Siamese network. So basically we all know that Siamese network is a type of neural network that uses the same weights to process two different input vectors and generate comparable output vectors. So we'll see how it works. So for that we will be working on fruit 360 data set. So basically this is a data set of images containing fruits and vegetables. So this is the detail about the data set, right? Like what kind of fruits that is containing. You can pause the video and read it. So let's get started. Before starting, we'll request you to please subscribe the channel. If you like the content, please do like and comment your query and your requirement so that we'll be working on this. So let's start. So dataset property, the image used here are simple from the original image, sample from the original image. Total number of images used are this one. Number of classes, that means we have 30 fruits and vegetables, and this is very important, that is the image size. We are using 100 by 100 pixel. Dataset source, you can use to get the dataset from here directly, right? So to get any licensing, so you can also check out this link also. Now import necessary library, import regular expression, numpy as np, pill for image, cv2 random for generating random numbers or random samples, sklearn dot model selection, import train tester split, keras import backend sk. Now using the activation layer, input lambda, dense, dropout, convolution 2d, max pooling 2d, flatten. Of course we'll be using models for like sequential or models, then using optimizer as ms rms prop. So finally tensorflow as tfs backend. Now initialize input values such as margin, input size, epoch, batch size, so that we can easily access it. So epoch, that means iteration will be 10, batch size is 10, again margin is 1, output class is 30, and image height and width is 256. Set the data directory for the data set. So importing path lib, again you can access your working directly. So we have this train data, so we are using into train data in this data directory. Now find all jpg files in data directory. So image count equals to length list data directory.glog, right, to access these jpgs. Now image count, so if we see the image count, so if we see the number of images, so we have this one 5047. Now get all image files of apples Brayburn class in a list called fruits equals to list data directory.zlog apple Brayburn, right? Now cv2.im read string fruits 0 and shape. Now image.open str of fruits 0, so it is opening this. So as we can see, this is an apple. cv2.imageRead converting fruit 5 to str and the shape, so that means read fifth image of apple Brayburn class, right? So again if we open the image to display it, so you can see that this has opened this image, right? Now length of fruit, so it will display total number of apple Brayburn fruits. So here you can see that we have total 164 because fruits is containing our this one right now. Generate a tf.data dataset from image files in a train directory. So train directory, so tf.keras pre-processing image dataset from directory. Now passing all these data directory validation split, that means 80% for train and for 20 for validation. Subset training seed 1 2 3, image size, image height, image width, batch size equals to batch size. Then found 5047 files belonging to 30 classes using 4038 files for training. Now generate a tf.data set from image files in a validation directory. Val ds equals to tf.keras.preprocessing image dataset from directory. So again you can see that passing all these necessary parameter. Now found 5047 files belonging to 30 classes using 1009 files for validation, right? Now storing classes name, so class name equals to train ds class name, print class name. So here you can see the class name that we have, apple, ribbon, apricot, avocado, banana, so on so forth, right? So on so forth, right? Now display the different fruits vegetable in the train directory. So here we are using the plotting for from matplotlib. Now passing the figure size at 10 by 10 for image labels in train ds dot take 1. For I in range 9, ax equals to plt dot subplot 3 I plus 1, plt dot im show image I dot numpy dot s type unit 8, plt dot title class name labels I. Now plt dot access off. So here you can see that if we plot all these, so this is what we got from this data set. Now separating and storing the train dataset image and labels. So train whole image, train whole label. So image label in train ds dot unbatch dot take -1. So it will append all the images into train whole image and all the labels in train whole labels. Converting the list into array. So of course we will get this train whole image, the shape of the image and the label, right? Now separating and storing the validation dataset images and labels. So validation whole image, validation whole label. For image labels in validation ds dot unbatch take -1. So here again we are appending all these images and label. Converting the list into array. So of course we can do np dot as array to convert it, like d type np dot float 32, and here you can see that it has converted them. So this is now for whole image shape, this is for whole label shape. Creating pairs for the training images. So here image pairs, so xy. So create a tuple containing image pairs with corresponding label. So these are the arguments, so these are the returns that we are getting from this function. So as xy, x list containing image, each index in this list correspond to one image, whereas y list containing labels, each label with data type of int. So what it will return? Tuple containing two numpy arrays as pairs of sample labels, and where pairs of samples shape is this that we got here, and label are a binary array of shape to length x. So x is basically the number, right? So now you can see that we are applying the same thing here, and it will return like this. Now printing train whole label dot d type. So now it has become float 32, converting the data types of the label of integer. So train whole labels dot as type unit 8, and validation whole label dot as type unit 8. Print train whole label dot data type, print validation whole label dot data type. So you can see the unit 8. Make trains pair, so pairs train labels train, right? We are getting these train values from make pair. Similarly we are using for make validation pair. So we got train pair, we got validation pair, and we got label train. Now splitting the pairs into two variable for training. So xtrain1 pairs train, right? Similarly xtrain2, so this one we got the shape of xtrain1 and xtrain2. Similarly we will be doing x validation 1, x validation 2. So this is the shape for them. Now image shape equals to xtrain1 dot shape, and image shape you can see that measuring distance between two vectors images. So Euclidean distance vector, right? Find the Euclidean distance between two vectors. So this is the argument returns what we call the decoration. So it will basically return tensors containing Euclidean distance as floating point value between vectors. Now defining the model. So of course input equals to tf.keras.input shape img shape, passing all the required layers like batch normalization, convolution 2D, average pooling 2D, convolution 2D, average pooling 2D, flatten, and finally the batch normalization and dense, right? And embedding network tf.keras.model input, and the passing the x here. Input 1, input 2, so containing input layer of image shape, right? As mentioned above, Siamese network share weights between tower network, so sisters network we can say. To allow this, we will use some embedding network for both tower networks, tower 1, tower 2. So embedding network input 1, embedding network input 2. Now merge layers, so tf.keras.layer lambda, right, passing this, then again batch normalization dance, and passing the input parameters. Now loss function, defining it, so margin equals to 1. Basically it will provide the contrastive loss on enclosing scope with variable margin. Argument margin integer defines the baseline for distance for which pair should be classified as dissimilar, minus default is 1. Returns contrastive loss function with data margin attached. So defining contrastive loss, y true, y prediction, calculate the contrastive loss. Argument is this, returning a tensor containing contrastive loss as floating point values, right? So this one. Now model compilation, so if we see the summary of the model, so here you can see that total parameter, trainable parameter, non-trainable parameter, fitting the model, so history equals to Siamese dot fit, so passing all these parameters into this fit function, then it will go to 10 epochs, right, as we defined earlier. And you can see the loss we have and the validation accuracy we have. Now accuracy versus epoch, plotting the matrix, so it will basically plot the given matrix from history, and these are the argument and returns accordingly, right? So here you can see that it will plotting basically the matrix. So model accuracy, this yellow one is basically for validation, and this is for train, right? And this is what the contrastive loss, you can see that decreasing in both the train and validation. Now doing model evaluation, so here you can see that the accuracy, right, the test accuracy and test loss, sorry, test loss and test accuracy. So the accuracy is nearly 84%. Now visualize the predictive model, so create a plot of pairs and a label and prediction if it is tested data set. So all these are argument that we have, and returning the plot, of course. So again doing the same thing, if you run this, it will show you the plot for that. Now model prediction, so prediction equals to Siamese dot predict. So now time for prediction, now time for prediction. So here you can see visualize pairs value, labels value to show 3 predictions test true. So here you can see that for true, so basically these yellow point, you can see that true 1 prediction 56. So again here true 0 prediction 10, here true 1 prediction 98. So this way you can apply Siamese network in it. So this was all about this summary video of the Siamese network. Hope you enjoyed it, hope you were able to get the topic. If yes, please do like, share and subscribe. So we'll be back with the next video very soon. Till then, all the best, take care, have a good time.